Everyone, good morning to our friends on the West Coast and whatever time zone you might be viewing this video in at a later time. Yes, it is available for watching later on. So today's topic, we're going to be talking with Martin from Telos. Many of us on this screen have very, very fond memories of Telos products back when, remember those old days when phone lines were still available? Remember that? POTS. Yes, I know there are still out there, but finally the TS1, the Link, the Link was one of those products where I couldn't live without it, right? It's like, you want PLs in this? Boom, here we go, right? And so we have a lot of fond memories of how they did what they did, but more importantly, how well they did what they did. And who would have thought you could sat at dinner and argue over phone hybrids? But we did, and we're good at it. We're good at arguing, but we're passionate about what we do. And I think that's something that we'd all agree Telos is brilliant at. Telos is brilliant at being passionate about the market segments they're in and being best in class. So today we're gonna stay in Intercom, but it's a new pivot for us. This idea, Martin, I was talking to you about earlier and looking at the website. When I first saw it announced, I'm like, okay, so a matrixless matrix, or it's like saying I've got a routerless router. Well, yeah, it's like we're gonna disrupt, and what better time to disrupt the market than when nature has disrupted us, right? And so I think we're already sitting here going, hey, you know what? I'm gonna look at things. I could look at things differently than I ever looked at things before, and I think that applies to technology right now. So I'm pretty pumped about this topic. AES 67 audio over IP is not new, but the scale of implementation right now, that maturity is where we're really seeing the confluence in the marketplace. And it's exciting to hear where you're going to take us through that, Martin. But before we do, we've got a few more attendees joining, so we're just going to give them a couple more minutes before we get in, or a little more time before we get into the presentation. But Pete, Mac, welcome. Hi.
Yeah,
you're looking good. Mac's going with the little more little pattern shirt today.
yeah. Pete told me it was warm outside, so I decided I got sandals on. Decided to go with a little more tropical shirt.
There we go. There we go.
Oh, you know better than that. You do. But anyhow, let's talk about Q&A today, and how we're going to go about doing this. I know we've got probably some new folks watching that haven't joined us before. So kind of talk us through that that process before we get into talking with Martin.
Sure. But first, very brief anecdote. My first experience with audio over IP happened years before Dante was announced, when audio over IP was completely unheard of in our live world, but it was very big in radio. And Telos Axia Livewire was my first exposure to audio over IP. And while I was resistant to it the first time I used it, after that first time, I was convinced that that was the way we should do audio in the future. That, and the epitaph was being written on the tombstone of analog audio. That was,
yeah, right, exactly.
That was everything, everywhere, all the time was going to be the future.
Yeah, but anyway, and yeah, it feels like it just happened overnight, but it didn't. Right?
It didn't happen overnight. It's been a long time.
Here. And to that point, we're also, we're talking about established, not just companies, but established processes that have been vetted over the years. So Pete, you want to talk Q&A?
In your GoToWebinar control panel, there is a pull down tab called questions. You can type your questions in there. Not all the questions from everybody will be viewable in there to you. We're going to be vetting them and passing them on to Martin. there is a section also called Handouts, which has the PowerPoint he's using, but it's exactly the same as he's going to be displaying. So you don't actually have to download it right now, because you'll see it on the screen with his illuminating words. The handout, as well as a list of the questions, will be available in a zip file along with the video on our website. So feel free to ask questions about anything. We'll get to them when we can. So Martin, it's yours.
Thank you very much. Should be sharing my screen now, I think.
And you are.
Excellent, great stuff. Okay, well, welcome everybody, and thanks for joining us this afternoon, or this morning, or even this evening, wherever you are. So as well, what a great setup from the guys, and I really appreciate that, and I hope I can do the introduction justice. But anyway, I'm going to talk about the Telos Infinity system. First thing I'm going to do is go through a PowerPoint, and I hope everybody stays awake for that. And then I'm going to go live onto the system that I've got running over my both shoulders, right by my head. Anyway, I've got an Infinity system running behind me, and I'm going to go live onto that and show you how easy the Infinity system is to use. So to kick us off, the first thing I'm going to do is give us a short history lesson, and we had a little bit of that from Mac and Kelly just now, talking about the history of audio over IP. And the first slide here is well, I always say this is a picture of me in the year 2003, but it isn't really. They're definitely not the slacks and shoes I was wearing in 2003. But that's what audio systems engineering was like back in the dark ages before audio over IP, and that's particularly pertinent to my career history, because I was in systems integration for a very long time, building broadcast facilities and installing Intercom around the world for various systems integrators. And I know exactly what it was like to be stuck in the back of a rack like that, trying to find the end of an analog audio cable that's out of phase or not working, or something along those lines. So I'm going to talk just a little bit of history about where audio over IP came into being. So in 2003, we introduced Livewire. So Telos have been working on Livewire for a while, and 2003 was the launch of the Livewire protocol. And the very first customer was to use audio over IP in broadcast was Auburn University down in Alabama, and their first system using Axia, the infant Axia consoles, went live in 2004. Our friends at Audinate followed up with the Dante protocol in a completely different part of the market, in the AV space and live sound, and they've really dominated that space since then. And now they're alongside us in the broadcast industry too. Another company that we all know well, Wheatstone, introduced WheatNet in 2008, and another name that many of us will know, ALC Networks, introduced the Ravenna protocol in 2010. And so at this point, the QSYS is out there too. I haven't got that in the slide, but QSYS was introduced as well, and some other people playing with audio over IP. And this led the industry to look at all these different proprietary standards coming into being, decided to do something about it, and set up the X192 working group, of which Telos and the guys at ALC Networks were certainly founders, working with AES. And the AES 67 interoperability standard was ratified in 2013 to create a standard of transport between all our various systems. And back in 2013, it wasn't plain sailing by any means. So the MNA, the Media Network Alliance, was an evolution of the X192 working group, with the brief really to go out and to start to work together with manufacturers like ourselves and to figure out how we get our products working together with a true interoperability. With that in mind, and bearing in mind at this point we're only really talking about audio, we started to see other media over IP standards come out, and that led about to the birth of AIMS, the Alliance for Media over IP Solutions. And that was really a means to get video over IP, control over IP, and the whole suite of standards lined up, so that everybody was on the same page, and we weren't continuing with the proliferation of different proprietary protocols. Leading finally, if you like, well, because this is still ongoing, but SMPTE published SMPTE 2110 back in 2017. And that's the media over IP standard that encompasses all those things that went before, to produce an interoperability for video, audio, control, and other elements, of which advertisement and discovery is still a hot topic. But AES-67 was ratified as the standard which would move forward as part of SMPTE 2110. So that brings us kind of to where we are. And all this time, just a bit of a recap on what Telos was up to. Well, in case you don't know Telos, or all you know about Telos is that we're a company that make POTS hybrids, which is really not true at all. Started the work on Livewire in '98, as said on the previous slide, launched it in 2003, which gives us a sort of 22 years of unparalleled experience developing an audio over IP standard, of which now there are way over 100,000 devices deployed around the world running the Livewire protocol, and many of those, as Kelly alluded to, and Mac as well, are in the radio space, not necessarily in side of the industry that you may know, but it gives us a foundation on which to build an intercom system. Livewire plus AES-67, which is our version, is fully AES-67 compliant, has its own device discovery and advertisement, which is used within the Infinity system, within the suite of products, but is expanded outside of that. And we are committed to SMPTE 2110, so we're working with SMPTE all the time to ensure that we're part of this global community. So there's a few of the products that Telos make that you might not know about. Mixing consoles for radio and television, for any sector of the audio industry that needs a console, and these are all pure IP devices. So everything you see on the screen there, whether it's an analog to IP converter, or whether it's a VoIP phone system, or a console, or even a box of mic pre's, this is all audio over IP stuff. So that leads us neatly onto Intercom. Life as we know it within the Intercom world right now, for most of the industry, still looks like kind of a bit like that. Matrix comms is still prevalent. So in this diagram here, which isn't meant to look like anybody's intercom, so I do apologize if anybody working from our competitors is looking at that thinking, hang on, is that one of my panels, or is that one of my matrices? Well, it's really meant to be a generic representation of what matrix comms looks like, and it's still pretty true today that matrix intercom systems are a central core where everything eventually goes back to this engine or this matrix frame in the middle, whether it's a VoIP codec connecting telephony or remote panels, or whether it's a server connecting cell phone applications or LAN connection connecting panels. Even when you are using IP, you've still got to get back to this central core, no matter what. And when we started to think about Infinity, we didn't think that was something that was necessary anymore. We wanted to break that model. So I can't really say that a matrix isn't practical. I mean, it is practical, and these are some of the reasons. it's a great way to switch cross points. Input comes in, somebody wants to talk from point A to point B, they fire a cross point. If two people want to talk to A and B, want to talk to C, then a router is a good way to mix. Obviously, we use them all the time. So party lines, IFBs and groups, all those things require mixing. These are all occasions when more than one person might want to talk to somebody at the same time. So it has to be a mix element, and that's not so easy to do when you don't have a central core. Matrix usually has RAM, so it can store configurations on board, so it's self-contained. Cross points have gain control, inputs and outputs have gain control. Well, you have edge connections for everything that's in and out. Signal detection and monitoring is something that's easy to do, and matrices are by nature have a degree of resilience through power and CPU redundancy. And over the years, connectivity has expanded so that IP, analog, AES, MADI, VoIP, all of those things are connectivity options. And over my career in systems and also working for Drake, one of the early matrix intercom companies, I've seen all that evolution firsthand. And matrices are a known commodity, so people listening to me talk about this may be feeling comfortable with a matrix solution and think that IP is some kind of black magic. Well, hopefully we can dispel that. So anyway, when isn't it not so practical? Well, this is for any system designer out there who's ever done this, whether you're doing a live show or you're building a broadcast system, you'll sit down with a sheet of paper and you go, right, I'm going to build an intercom system. How many operators have I got? What do they need? Who needs a panel? Who needs a belt pack? Who needs a wireless channel? How many POTS lines have I got? Or how much telephony do I need? How many virtual panels, whatever it is that I've got out there, and I have to sit down and I have to come up with a port count, and then I have to look at the brands available and figure out what size matrix I'm going to buy. So a matrix lacks that flexibility because it's limited by a port count, and if you decide you need 88 ports, then you might have a contingency and have to go up by 10 or 20% so that you've got some room for expansion. Channels within a matrix can be limited by the TDM bus structure. So there might be, I don't know, 96 physical ports and 256 channels that can be handled inside, but there's a limitation there. It can be difficult and expensive to trunk systems together. I know that from bitter experience. When you're trying to trunk matrices together, you have a finite number of trunks between them, and you have to worry about priorities between somebody who's on frame 1 talking to somebody on frame 2 and stuff like that. And there's a whole lot of maths that goes in that. Take up a lot of rack space. And as we said in the previous slide, everything cables back to a central point. And even if you are using an AIP, an IP connected matrix intercom system, you've still got to buy the Ethernet fabric. You don't get away without having the switch fabric, so you still need that. And by its very nature, a matrix is a single point of failure. If you lose a matrix card, well, you've lost 8, 16, however many endpoints. And they can be heavy and power hungry, which can be an issue when you're building a remote plant or fly pack or a truck. All these things add up. So matrixless intercoms gets us around to infinity finally. Well, the first thing about it is there's no costly central matrix, so that piece doesn't exist. And when we set about to do it, our development team, who had built an IP intercom system, actually the Axia brand under Telos already had an IP intercom system, but it was really only point-to-point comms for the radio industry. But they didn't have a lot of experience in building a more comprehensive product. That's where I came in. I was brought into the company to help guide that. One of the first things you have to do is think about, well, it's an intercom system, so people are going to want to sit in front of components that they recognize. Panel's got to look like a panel, needs a gooseneck mic and some keys with obvious labeling, so you know what button to press when you want to talk to the camera guy, girl, and you need volume control and speakers and headset connectors, the usual stuff. And you want software tools that are familiar as well, so we don't want to reinvent names. You know, we use the name Party Line because it's because that's what it is. People know the term Party Line. We don't want to reinvent everything, or even though we're reinventing the topology. We wanted to build something that is fit for purpose, obviously, but can go beyond what's gone before. And we're relatively new. We haven't had our system out all that long, so it's developing all the time, and we're getting more and more features on board. Standards base is a really, really important thing to do, and that's something that the Infinity system is based around. As you learned from the early slides, IP standards are in the DNA of the Telos Alliance. We're part of the founders of all of that. So it was natural that we would build a non-proprietary standards-based system. Obviously, not everybody's using all IP, and we still need interfaces to baseband, as well as other audio over IP equipment. So that was part of the brief, and a scalable and resilient system. So you want this thing to be able to hold up as well, if not better than a matrix, and to be able to be bigger than anything that's gone before. But above all of this discussion, we wanted to get away without having a matrix or any kind of engine whatsoever, by using a purely distributed architecture, and we'll get on to how that works in a short while. So how does it break the matrix model? Well, it does that. It uses a DSP core in every device, so every belt pack or panel has its own DSP engine, and they're big, ugly, powerful DSP engines as well. So there's a lot of capability under the hood in every Infinity panel. So the more devices you add, the more powerful the system becomes. And if you like to think it that way, you have the equivalent of a matrix, but in a distributed form. So my 5 panels behind me have got a massive amount of power to handle anything I might throw at it. And the bigger the system, the more power you have. So it's kind of the converse to a matrix model, whereas you fill up the ports, you have less headroom, less room to expand into. With an Infinity system, the more devices you add, the more capability you have. So it's the inverse relationship, really. Configuration tool is called Dashboard, and the Dashboard agent maintains a database of the configuration, and it gives you the user interface that allows you to configure the system. But it is a configuration tool. It's not required for systems operation. We're not doing anything. We haven't got any subterfuge. We're not using a PC somewhere to port audio around. We just set up the system with Dashboard, and that it is called Dashboard. It's the software product. We've built a resilient architecture, and I'll show exactly how we've done that in a slide coming up. We use native integration with our own products for baseband connectivity, and also the Telos VX for integrated telephony. And the VX is a great product. It's a VoIP engine that connects to a SIP server or a SIP PBX, and is the equivalent of a good old Telos hybrid, but in a scalable form, the likes of hasn't been out there before. So a Telos VX engine, for example, can have anywhere from 8 to 120 hybrids in 1U. If you think about that, that's 60 U of dual hybrids condensed down into 1U, with all the flexibility and capability of audio over IP. And everything connecting on the network that isn't VoIP is natively audio AES67. And although it is a new system, Infinity is new, as I've said, and I think we've established Telos is a company with a proven heritage in audio over IP. So the products that we have out there are many pieces, not physical pieces, but a lot of intellectual property that's gone into making the Infinity system that's already out there on the air in thousands of radio stations around the world. So a few additional benefits of the system. I'll whiz through these a bit. It's plug and play. Your devices plug into the switch. You run the software and you discover the system, and you can start configuring from the word go. So great for broadcast, but also great for live sound environments and stuff like that. Simple stuff like being able to daisy chain panels and belt packs, so you don't use up your network ports quicker than you might want to. Configuration tool and on both the devices and on the UI is HTML5, so all you need is a browser to connect and you can configure. You don't need a dedicated application. Infinitely scalable. I love saying infinitely scalable. I mean, it's where we got the name from. You've got to be a hell of a network designer to build a 30,000 panel intercom system, but in theory you could do it. You could build an Infinity system with tens of thousands of panels, should you wish to, but most of them are a lot smaller than that, obviously. Planned and ad hoc changes are really simple. Again, you know, let's say you've started a production, you need an extra panel or an extra couple of panels or extra belt pack, you plug them in and you're off and running. So as long as you've got space on your network, you're good to go. And talking of which, if you have a media over IP infrastructure already, chances are it'll be compatible with the Infinity system. And we have tools within Infinity to build local intercom systems, regional, national, even global. And when we get onto the system live, you should be able, we'll be able to see the tools that we've got for connecting across the globe. And although I won't be able to do it today, as my colleagues are got other things that they're up to, but I can communicate to colleagues in South America, in Europe, in China, all over the place from my couple of panels that are behind me, just straight onto the internet. And lower TCO, that's something that we say about the Infinity system that's true for the most part, that not having that cost of the central matrix is an obvious starting point. That makes a big difference, but also your ongoing costs, your design costs for one thing, your installation costs, not having to have the floor up and run back to a central point every time you need to add a connection. And also over the lifetime of the system, it's easier to maintain. You don't have to keep taking the whole system down every time you want to make a large change that you might do with a matrix system. So lower TCO. And also, this one takes a little bit of explaining, but communication and contribution audio are on the same network, so they become part of the same thing. We're talking about audio over IP here, so the audio that exists on your mixing console, let's say it's the pre-hear mics, you know, on your mixing console, they exist on the network and they can be pulled straight onto a key on the intercom panel without having to go through a patch or go through a converter or anything like that. If your production system is audio over IP and your communication system is audio over IP and they're on the same network, then all the media is interchangeable between them, and it makes the design and functionality much more elegant. So let's get down to brass tacks. This is what we have so far. These are the Infinity products that are out there. One new master panel, expansion, desktop, belt packs, the dashboard software, Infinity Link, which is our VoIP codec for connecting to remote sites, and the ubiquitous branded Infinity headsets. I should explain, excuse me, full and base versions of panels. A full panel is one with auxiliary I/O, analog I/O on the back, and GPIO as well, and the base version does not have those facilities, and as a result is a little bit less expensive. Less expensive, that's a bad term, is cheaper. That'll do. We'll get on to these products and I'll show you them for real. So that's the suite of products right now. You can see the belt packs there, desktop, the 1U panels, the link gateway, which is the silver box at the top of the stack there. That's a VoIP codec. It's a box of VoIP codecs, and then there's a view of the software in the back. Let's go through them all one at a time. All right. So this is the 1U panel, MP16 master panel, 16 key. It has 16 talk listen keys. If you think rather like the KP32 or the RTS panels, it's push down to talk, it's flick up the key to listen, and the 16th key and the red key in the right hand corner there is reply to last caller. So that is always a reply key. You can't configure it to do anything else. There are currently 3 shift pages on an MP16, so you have 45 assignable keys that can be used for absolutely anything. You can change the colors, change the text, change the labels, of course. Volume controls, auxiliary volume control for external feeds, and master volume control for comms. 4-pin headset, gooseneck mic, and internal speaker. They are, if anybody was going to ask the question, they're about 80 millimeters deep, which is not good with Imperial, coming from a European, well, former European country. I guess that's about what, 3-4 inches, something like that. On the back there, you can see we've put the auxiliary audio, and we've put them on XLRs because we thought that was a good idea. Makes it easier to rig. The left-hand line in is a mic line switchable. You can use that as an external mic, or you can use them for as an insert point. So you could plug as a program quality mic pre on there, you can plug a decent microphone in, and it will be transmitted as an AS67 stream onto the network. So you could pick it up on a console, for example. So, you know, maybe that panel might be used in a location where you've only got you've got your talent, an engineer, and your talent needs to get on air. Well, you can plug the microphone in there, stream the audio over the network from that rear XLR, and put it onto the console and onto the air. And that's what we mean by mixing contribution and comms on the same system. Line outputs for external speakers or for monitoring. They can be a slave connection for the rest of the network, or they can be something to do with the comms. And then these panels are PoE, 1 gigabit connection, power over Ethernet. Secondary port is used for daisy chaining to an expansion panel, or it can be used for VoIP connectivity to the internet. That could be connected to an internet connection and used with a link codec, or it can be used for resilience if you're using it in a SMPTE 2022-7 or a bonded failover mode. The secondary port can also be used for that. And then there are 5 GPIs in and 5 GPIs out, so that can be configured over the network. Okay, so that's the expansion panel. Big difference here, 20 keys. You plug an expansion panel in as a pair with a master panel, and it'll switch through the 3 shift pages as you go. You can have up to 9 expansion panels connected to a system. So you can have 10U of comms in any one position. That's not an arbitrary figure. I came up with that because I worked on a BBC installation once, and the sound guy had 10U of comms. So I thought, park that in my brain. So if I ever build an intercom system, 10U is about the most we'll ever want. So that's where that came from. It's madness. 10U of comms. There you go. Desktop panel looks like that. It's exactly the same as the 16 key rack mount panel. It's just a different shape. It's designed to look good in a modern facility. It looks a lot better than that image does. but that's designed to look cool in a modern production facility. And you can buy it with or without the I/O on the back. It has exactly the same provision as the rack mount panel. BP2 belt pack. So this is the 2-channel version. We've got a 4-channel version coming out next month. The BP2 connects over Ethernet, power over Ethernet, Ethercon connectors on the back, so it can be used in rugged environments where it might get smashed about a bit. The 2 talk and listen channels can be used for anything, so not just party lines. You can use them for you can use it for IFB, for groups, for peer-to-peer communications. The 4-channel belt pack will use the 2 call keys for channels 3 and 4 respectively, and also has a mode where channel 4 can be used as a reply to last caller key. So it'll be a 3-channel BP with a reply to last caller. And the belt pack can actually run VoIP codecs as well. So you can plug a belt pack directly into the internet. So it can just be, you can just take a belt pack to a location, plug it into an internet facing switch or WAN facing switch, and use it on its own, built-in codecs. It needs PoE, of course. Also has a built-in microphone and speaker, so you don't have to use it with headsets. You can use it as a little desktop panel, and the speaker's pretty good actually. It's the same speaker that is used in Garmin navs. So mentioned the Infinity Link codec. It uses OPUS. OPUS is our VoIP codec. It's the same codec that's used. I'm probably talking to you over OPUS right now. A lot of these conferencing systems use OPUS, or use the Silk version of OPUS. I know Skype does. I think Hangouts does as well. It's also the same codec that's used in our friends at ClearCom use it in the LQ system. So if you've ever used that, you know the audio quality is great. And all of those devices on the screen there can run a link codec. You can run 2 codecs on a belt pack, either 4 or 8 on a panel, and you can run 8 or 16 on the dedicated link gateway. And the gateway has dual AC power on the back. It's not a PoE device, but as AC power, so dual redundant AC power, dual Ethernet connectivity as well. And what basically happens with Link is any of the codecs that are running on there, their inputs and outputs are converted to AES67, and those AES67 4 wires, if you like, and think of them as 4 wires, IP 4 wires, they're available on the network, and they can be used by any other device that's on the network. So you could use an Infinity system to backhaul audio for contribution, should you wish to do that. We have customers doing that right now, or you can use it as a comms connection. But it's really super flexible. Once it's on the network, it comes out as an IP stream. So looking at connectivity, very simply put, there we go. Infinity devices connect to an Ethernet switch with power over Ethernet. You connect a laptop or a PC or a server that's running dashboard. It will discover those devices. You can browse to that connection from another PC, or from a web connected device on the left hand side, or you can use the same device. In the case here, when I go onto it live, I will be using my laptop to connect to the Infinity system, and I'll be browsing from the PC I'm talking to you on into my laptop. In fact, you see my laptop over my shoulder there, and I'll be browsing onto that and connecting to the Infinity system. So very, very, very simple to connect. And as you run the dashboard up, it discovers the devices and creates the screen that you configure the system with. Connecting expansion panels can be one of 2 ways. You can either daisy chain them and use a PoE injector from the master panel to the expansion, or you can use a home run back to the switch and use PoE from the switch. So it's one of two ways, and then you can continue daisy chaining them. Expansion panels are really good to have on the system because they're a DSP block that doesn't do anything else apart from have some buttons and act like a big part of our distributed matrix. So the link system, just in case you didn't really catch what I was saying or it sounded confusing, hopefully this will make it a bit easier. This drawing shows broadcast HQ on the left, or a main facility on the left with a link gateway device that's connected to the local area network where the rest of our Infinity system exists, and connected over the internet or over wide area network or indeed VPN to two affiliate locations, the top one and the bottom one on the right. Both of those are running link codecs on an MP16 panel. And so depending on the number of codecs you've got, you either have 4 or 8 trunks running over the internet, bidirectional trunks between the broadcast HQ and the two affiliates on the right hand side, and they can be used for whatever you like. So they could be used for party lines, for IFBs, for group connections, peer-to-peer, up to you. But that's as simple as the system gets. So connectivity to other Telos devices, well, plug for our own gear here, of course. X nodes down the bottom right, there are IP to baseband converters available in analog AES3, SDI, mic, and GPIO converters. They've been around for many years, and there are tens of thousands of those installed around the place. Our consoles, and of course our VoIP, and any other Telos product that exists that uses audio over IP, and most of them do, can connect to the same system and become part of the production system and part of the intercom. So if you look at that very simple diagram there, you can imagine that somebody calling in via the VX VoIP unit on the telephony side comes into the system. The director can intercept that call, can talk to them, give them a countdown to put them on air. That stream can then be picked up by the mixing console, and the director can have an IFB talking over the top of the mix minus that's being returned to that telephone caller, and all of that exists on the network. Super simple and easy to set up. That kind of connectivity is what really sets the Infinity system apart. That's all done without any central core, even to the point where you could say that the Ethernet switch is the router. Okay, moving on. Let's say you've invested in a lot of IP equipment that isn't made by the Telos Alliance, and there's a lot of it out there. Well, you can connect in exactly the same way to an Infinity system. So whether it's third-party AES67 gear from many of the many manufacturers out there, or if it's a Dante device, I don't know, there are hundreds and hundreds of those. Yamaha console is a good example. Focusrite gear. If it's running in AES67 mode, and nearly all of it can now, it will advertise the presence of the streams using SAP, Session Announcement Protocol. We can recognize that in our UI, and we can pick up those streams and make them part of the comm system. Going back the other way, we can take our party lines or our IFBs or our group comms, whatever it is, or just peer-to-peer. We can advertise that stream with Session Announcement Protocol. The Dante controller can pick it up and can connect back to your Dante ecosystem. And then finally, SMPTE 2110-30 is compatible with our systems. There aren't many differences between AES67 and 2110, but it comes down to PTP profile and some other nuances. But Infinity can can work in both domains. So dashboard, we've talked about it a lot. There's a picture of a dashboard screen. I'm going to go live onto dashboard in a little while, so I won't explain what's on that screen, but I will explain dashboard. Talked about agent and host as the services that run and create the configuration tool, and I already talked about it using HTML5. You can have multiple logins, so you can have users and administrators that log on. They can have different login credentials, and they can access different parts of the system. An Infinity system can be logically divided up into something called zones. So if you have a lot of devices and they're distributed across studios, you can create a zone for Studio 1, a zone for Studio 2, a zone for master control and everything else. Anything can be in a zone. It can be a party line, it can be a group, it can be a single stream, or it can be a device like a panel or a belt pack, but anything can be put into a zone and logically grouped so that when you log onto the system, if you only want to see Studio 1 system, you can use Studio 1 system. If your login only allows you to see Studio 1, then that's all you'll be able to see. A scene is like a snapshot or a memory. Generally works within a zone, but it can work across the entire system, and a scene is a way to take a snapshot of the configuration of any element within the Infinity system and then recall it at a later date. So I guess the most obvious thing now is news show. Take a news show in Studio 1, take a snapshot of the 6 p.m. news show, and you can you can save that snapshot, and then maybe there's another show that you use in the same studio at 9 o'clock. Maybe you do the sports show and you don't use as many telephone lines or whatever. You can save that as a different scene and recall it. You can also work live or offline on scene, so you can edit a scene and then push it live. Each login client can have restricted access. We talked about that, and scenes live or offline. Dashboard Advanced also logs all system activity. It looks for alarm conditions and things like that. It provides a constant log. So if anything happens that you know, if they find a bug or something like that, you want to go back and find who pressed what button when they shouldn't have done, you can go back and see all the system activity. Features in dashboard, well, I talked about unlimited party lines, groups, IFBs, and virtual ports. A virtual port, I should say, is a means to create a logical pairing between a source and a destination, between an input and output. Unlike a matrix, we don't have physical ports, so we don't necessarily determine when there's a logical relationship between an input and an output. They are independent unless you determine that they are part of the same thing. Configuration is drag and drop. We've kept it really simple, and we've done that quite deliberately so that anybody can use the system with a minimum of training. All the audio is native audio over IP, AS67. We talked about that before. Multiple simultaneous users, GPIO support for when you need that. Devices can be copied or cloned, and that's super simple. I'll show you exactly how that's done. Again, it's done with drag and drop. We have intelligent search tools, so when you're trying to find your way around a big system, it makes it easy to find the element that you want to lock onto and edit. And we can do live and offline configuration. Some of the latest features that are in there, I'm going to run through these pretty quick. So I'm very conscious of the time, and I don't want to shortchange anybody when I get onto the live system. So we have on board right now, we have the SAP discovery and advertisement, the Dante connection tool that I talked about. We've added Vox detection on there so that any incoming audio stream, no matter where it comes from, it can be assigned detection so that it can flash up on a panel and tell you somebody's calling you. You can put noise gate on it if it's a noisy source. You can assign key triggers to it. So if somebody somebody talks to you on a device that doesn't have well, it has a PTT switch but isn't part of the intercom system, so it doesn't send a control trigger, you can force a key into a listen mode based on Vox Detect and it going above threshold. So you can force listen with Vox Detect. You can even force listen and talk with Vox Detect. Virtual ports that she talked about are logical pairing of an input and output. If you use them in a party line, they have a built-in mix minus. That's really important if you think about it. Let's say, for argument's sake, that your camera comms is an analog connection, and you create a virtual port for one of the cameras, for camera 1. And you put the cameras into a party line. Well, the last thing you want is for camera 1's mic to talk straight back to camera 1's earpiece, camera 1's headphones. So any virtual ports that are logically pulled into a party line automatically mix minus, so they can't talk back to themselves. We have a device firmware inside now, which is linked to zones, which means that if you get a firmware update and you want to you are on a live system, but one of your studios is dark overnight, you can send the updates to all the panels in that studio via the studio zone, or you can send them on block to everything. But the device having the firmware updater inside zones is a really clever aspect of the system, because it means that you can determine exactly when you do your updates so that you don't disrupt live activity. Multiple zones and multiple scenes, yeah, we talked about that. That's all on there and live and running. ISO keys, something we kept getting asked for. It's a pretty obvious thing, but it was one of the more recent additions to the system. ISO keys for typically for camera comms. And now we have remote control of panels and belt packs, which is really cool. For that time when somebody leaves a key talking across the entire production party line and goes off for lunch, then you can hone in on that panel and turn the key off remotely. Never happens, right? Device firmware out of date alert. That's really useful tool if you log onto a system and somebody's somebody's taken a panel out of store and plugged it up, and it's 5 months out of date. It will flag up with a little blue icon to tell you. 22-7 and bonded failover modes for redundancy. That's actually the next slide. I'll show you how that works. Stacked and ganged keys are coming soon, and so is the 4-channel belt pack. But I talked all the way through that without showing you it's me forgetting to click the button. Sorry about that. But those are the features coming soon. Network resilience. I'm just going to leave that drawing up there for a second for you to look at. So this is how network resilience can work using the firmware update that's coming very soon for the Infinity system. So we do have a beta version now, and we've got customers around the world trying that out. And you can dual wire the Ethernet ports on the panels, so that you've got complete redundancy on there for either what's hitless merge 22-7 or bonded failover modes for a more simple and slightly less resilient connectivity. Okay, this is a system, actually is a real system that's out there. This is a broadcast facility somewhere in the world. I think it's in the US that's using Infinity, and this is a little look at their system as it stands at the moment. So the little candy stripe up the middle, think of that as being a switch. It shows the panels connected to the switch infrastructure. X nodes are the boxes on the right. There are 3 of them in a column with the analog IO red arrows shown connecting them to their respective component parts, so to a camera CCU for camera comms, to a CrewCom wireless system. CrewCom are our wireless partner, and Gary Rosen is up after me a little bit later this evening, and he'll be talking about the CrewCom system, which we like a lot. We connect to that using 4 wires, and it uses the same kind of ethos that we have for distributed system. So it's really cool, and connectivity to a console. In this case, the customer has a Cowrec Brio. They are for all this connectivity, they're using analog 4 wires. The Cowrec could be done with IP. We know that works. I've actually taken Infinity up to Cowrec, and we've done interop tests with that. Camera CCUs, we have built several systems now where we're connecting directly over IP to cameras, because Panasonic, Sony, Ikigami, I think Grass Valley have added AES67 connectivity to their cameras, and we've done the interop tests, and we know that those work. So in this instance, they're not using them, but maybe sometime in the future they will. And then you can see Link down in the bottom where they're using Link to connect to their truck for OB, and also using Link to connect to the remote office. So they can extend the Infinity system out. This one for you guys that are in the live space might be of interest. So this is a user report from Lollapalooza in Sao Paulo in Brazil, where the Infinity system was used for production across 6 stages for video production by TV Globo. And we work closely with the production company New York Digital. It's headed up by our good friend Danny Litwin, and he worked with our local agent Vizom down in Brazil, and put an Infinity system together to work on the production there, and it went extremely well. They loved the flexibility of the system and the fact that they could just add another panel when they needed it. It also worked in the 120-degree heat that they got inside the truck at one point. Heaven only knows, presumably the AC didn't work the whole time. And we're very, very happy with that. So that was a big success story for us. First Infinity system to go into a TV station was at KTBS in Shreveport, Louisiana, and there's a video online if anybody wants to check that one out. First radio system was at WGN in Chicago, and which I know is close to where Kelly's based. And the Shreveport KTBS system looks like that. Apologies for the rather rudimentary drawing, but my Visio skills aren't what they should be. But the IP infrastructure, the switch connects the panels, connects the VX system, much like the other one, and shows the 4 wires in and out of the 2 X nodes that were there. So each X node gives you 8 4 wires in, 8 4 wires out, and of course, being an IP device can be physically installed close to the baseband connection that you want to make. So you're not running cables back. If it's going to be connected to a console, you install it close to the console, or if it's going to be connecting your cameras, you install it close to the cameras. IMG, this is one I particularly like, and if anybody's involved in remote production, and remote production is obviously a very poignant thing at the moment. This is IMG, the global sports producer, American company, and this is a system that's used or was used while the soccer was going on, but was designed for use for the Championship soccer in the UK. And the beauty of this one is the interaction between us and another comms company, Riedel. So IMG's internal comms system is a Riedel Artist system. They use that for production throughout the facility. But they needed connectivity from Stockley Park in London to the different stadiums around the UK, and they had dedicated LAN. They're very lucky to have dedicated VLAN provided by our service providers in the UK. and it meant that they were able to connect the belt packs directly. Whether they're 300 miles away or 30 miles away, they could connect them directly to the Infinity system back at Stockley, and Dashboard discovered them and can configure them remotely over VLAN, as though they're in the same building, not using a codec, but using raw AES67. And it means that on those 2-channel belt packs, the production comms is in one channel, and that's provided by the Riedel system, which is connected to the same IP infrastructure. So basically, there are IP4 wires between Riedel and the Infinity system, and the belt packs are subscribing to Riedel comms on one channel and subscribing to Infinity comms on the other. So the engineering positions, camera and vision engineering positions, are using our desktop panels to connect to the camera operators, and yeah, a really cool system actually. Now, if they needed to use codecs, if there wasn't the connectivity, then they could install link codecs. It's just a code. Link is already pre-installed on every device. They just need to buy the code, and that LAN connection could be a WAN connection. This is another example of a system that's out there in the world. This is in the US as well. Similar system to the previous one, to KTBS, slightly bigger in that it's got more bits. But I won't dwell on this one. You've seen what it can do and how this goes together. But this one has a few other bits and pieces, like Lectrosonics IFBs are connected, and of course Lectrosonics now have the Dante version of the IFB, and that could be connected natively without the X node. Also using Link to connect remotely to their secondary sites. But yeah. And a Yamaha console again, and that Yamaha console could equally be connected using Dante. So nearly onto the bit where I jump onto my Infinity system, and before we do that, I'm just going to throw that diagram up there and just have a look at that while I just take a swig of this, so my mouth drying up. Apologize for the gluggy noises there. This is actually my Infinity system. It's the system that sat behind me. So I've got 5 panels plus one with an expansion up here, and they're connected through this little Cisco SG350 switch. And I've got the world's most expensive IFB monitoring unit here, a TSL PAM2. I used to work for TSL. I was the product manager for those, so that's why I've got one of those. And I'm using that for monitoring IFBs connected through my Axia X node. I've got 4 belt packs daisy chained up together, and I have a mixing console here as well, one of our IQ consoles and its engine. And almost everything is connected to the Cisco. This connection down here is a gigabit trunk between the Cisco and the small switch that exists on the console itself, and I'm using that to then connect to these 2 panels. Because I ran out of space on the Cisco basically, and I didn't want to daisy chain multiples, just to give a bit more flexibility and show how you can trunk the network. And then I've got a little microphone as well. So that's the system that I've got running next to me. And now
before we go on to the actual program, can we address these questions?
Yeah, sure. Yeah, let me.
I've got them here. I can tell you, unless you got it on the screen.
I can't see them at the moment. No.
Okay, that's fine. That's fine. Daniel wants to know, how much PoE power do the belt packs use? Do they have PoE pass-through, and how many can be daisy chained? Do you need PoE plus?
No, you don't need PoE plus. We measured them at full pelt. They run about 2.7 watts. So the quiescent current in normal operations probably about 1.8, something like that. So you can run 3 or 4 of them in daisy chain mode, depending on the cable length. We would say happily run 3 at 100-yard spaces, and that'll work just fine.
What protocol is used to discover devices on the network? From Peter Mason.
So our own devices use the Livewire protocol, and so that's what we use. If it's a Dante device, we use SAP. If it's from anybody else, then that's a manual process where we use the SDP file, and we connect that directly into the IO block that's inside the dashboard, and I can show you how we do that, or at least show you where it's done. I can't do it physically because I don't have anything to connect to, but
okay,
that's how we do that.
John Christie had several questions. Is it possible to connect the link gateway using OPUS to ClearCom Eclipse IBC32E IPA as if they are LQ devices or LQ devices as OPUS streams?
No, the short answer to that is no. I asked ClearCom about doing exactly that, and my understanding is that there is some data inside, encapsulated inside the ClearCom stream, that means that would not be practical.
Okay.
Would not be doable.
Is the log stored anywhere when the dashboard is offline, or do you need to keep the software running to capture the log?
It's actually dropped into a couple of folders, so you can get hold of them, and into, well, if they're most of it's text files. You need to know what you're looking for. And what we tend to do, we have 24/7 support. So what most people have done when they've needed to do this is they've just emailed over the log files, and our support guides have helped about.
Okay, and lastly, he asked, can Telos devices on a network act as a SAP service between Ravenna and Dante 67 devices in terms of discovery, or do you still need the Ravenna SAP software on a server?
You don't need RAV to SAP. I mean, it'll do the job if you want to do it. But if you know, with a Ravenna device, if you have the multicast address, then you can enter it manually, or you can download the SDP file and do it manually. We can read SAP directly, so we don't need to do that. But we have had people use RAV to SAP because they already had it installed, and that'll work as well.
Okay. I had a question. Can you force a 4-wire to hear itself?
Can you force a 4-wire to hear itself? Yeah, you can. I mean, what you could do with a 4-wire is, if you put them in a virtual port and you run them into a party line, then they'll reject. They have mixed minus. They won't send to each other. If you pull an input and an output separately into a party line without putting them in a virtual port, then they will route back to itself.
What if you wanted them in a party line and feeding itself back to itself?
You just wouldn't put them in a virtual port. You just drag them in independently as a separate source and destination. You keep them separate, and that would work. Yeah, we found that one out.
Typically, it would be when you're using a repeater.
Yeah. We found that out the hard way, because one of the early installations we had we put an old POTS hybrid into a virtual port, dragged it onto a party line, and the caller could hear themselves. So we had we had a very quick engineering upgrade to put that mix minus capability.
Right. Does the 4-wire out of date auto update when connected? The firmware out of date.
Sorry, could you repeat that one?
If I plug a panel in that's firmware out of date, does it auto update at that moment, or do I have to take it online and offline and update it?
You can do it online. You don't have to take it offline to update it, but it won't do it automatically. At least not yet. At least not yet. No, it won't.
So that firmware update can be done while it's on the system, and you get that notice, you can immediately go and do a firmware update manually.
Yes. Yeah.
Okay. Cool.
Yeah, no, it would be, I mean, it would be quite destructive if it auto updated. It's like, I was explaining to you guys before we came online, my PC auto updated itself, and I had to rebuild it this morning before this call. And you wouldn't want that with an Infinity system or an Intercom system. You wouldn't want it to go and auto update itself.
Why would doing it manually be any worse than, any better?
Well, you can choose to do it or not. I mean, chances are, if it's out of date software, it'll probably work quite happily. You might be missing a feature, that you want.
Oh, so it doesn't reject the panel out of hand.
No, it's a it's really a prompt that you're missing something.
Okay.
Yeah.
Does this have offline programming?
Yes.
And where do we get the software for that?
Offline programming is done with the dashboard software. So what you do is you take a snapshot, and I'll show you in a minute. You take a snapshot of the system, and then you go into the scenes memory and do your offline configuration there. If you wanted to build the system before you've got the system, you can pre-program panels and belt packs before they arrive. You know, if you know you've got a delivery and you want to start programming the system, you can do the panel and belt pack comms before the system arrives. What you can't do currently is do a spoof of a 4-wire.
So when the panels actually arrive, at that point you're basically setting up roles for your devices.
Yeah.
You then assign those roles to the devices when you plug it in.
Yeah, you literally what happens is you would create an offline panel, configure it, and when the real panel arrives, you'll drag the image of the offline one onto the online one, and it will take that image and it will become the panel that you designed offline.
Now, that being said, if I drag an online panel on top of another online panel, does it just copy it over to the other online panel? Replace it, basically?
Yeah.
So it asks you if you want to write over it. Okay, cool.
It asks you if you want to copy or merge. Yeah.
Got it. Edwin asks, is the belt pack connector in Ethercon? The answer is yes.
Yes.
He also asks, is the GPIO compatible with LiveWire control protocol? Is it the same pinout as the rest of Axia?
Yes, it is exactly the same.
Okay, just that's all the questions we have right now, but we did have the webinar system is having a problem with connecting people. So a lot of people have not been able to hear or see the show, and they will have access to the video obviously after. And we'll set you up on another date at another time to do the whole presentation again, just to make sure we get all of the people in. That's all I can say. But we do still have 25 people who are able to log on and are frothing at the mouth to hear the rest of this, as I am.
Yeah, I think we go into the demo, and like Pete said, we kept the recording going. That's why we didn't disrupt you, Martin, so that we wanted to get through that information. According to the website, their system is up and running again. But let's pick up at the demo here. And at minimum, people will have a great video. And then again, there was a lot of interest around it. So we'll obviously do this one again. So thank you very much. We appreciate it, Martin.
Great. Okay, so you should be seeing my login screen for dashboard now.
Yes, we do.
Oh, great. Excellent. So it has a login. It's admin because I haven't changed it. That's the default. So when I log in and go onto the system, as I said when I showed that diagram, I've got 5 panel positions and 4 belt packs, and I'll just describe the screen as we see it here. So in the top left-hand corner, we have the devices that have been discovered. So we have my panels, which are the squares, and we have my belt packs, which I always say look a little bit like a hamburger. Down, well, on the right-hand side, we have some navigation buttons, and I'll show you those in a short while. Then down at the bottom, we have the keys for the panel. This is the first key of panel 1. Panel 1, if you can see, has an expansion panel connected to it. If I double click on that, the edit page will come up, and you'll see I've got an expansion panel connected to it, which I dragged on to attach it. So I have 1 expansion panel in my system, and that's why it's showing the expansion panel on top. And then I have my 3 shift pages, of which only page 1 is populated at the moment. I also have GPIs associated with the panel, and I have GPOs as well, and I have some sort of standard functions. So speaker muted can send a GPO input call message, talk active state, might disable mute speaker, and then I can on the talk and listen actions, I can assign GPIs to any of those keys. On a belt pack, there are 2 channels plus an auxiliary program input, which is a separate stream, and the configuration of a panel for peer-to-peer comms is extremely easy. So on panel 1, well, what I'm going to do is just remove everything so far, so it's a completely bare panel. Just to prove it, I'll hit the manage button, and panel 1's web page will pop up in real time, and I'll go on to remote, and you'll see the image of the panel. It has nothing on it apart from the reply key, which tells me that panel 2 was the last person to speak to me. So what I'm going to do is I want a key to talk to panel 2, I want a key to talk to panel 3, panel 4, panel 5, respectively. I want those keys to be, and clicking on the keys brings up the key menu. Sorry, I want those to be force listened because this panel is the director, and I want the recipient to not be able to reject my call. And I want the key to panel 5 to be a different color because that's somebody I really want to talk to a lot. So now you can see that key color has changed. Now you have to take my word for it that this represents the real panel, because I don't have another webcam and I can't really zoom in on the physical behind me. But now this is the real panel. This is a look at what I've done, and if I click to talk on to panel 5 and just lean back behind me, you may be picking that up. I don't really know. Actually, what I can, you may have heard that. I don't know. But anyway, that was me talking to panel 5, and I can have complete control over these panels. I can also go over to the panel and hit the reverse key. And you'll see it's flashing away. This is what happens on the panel. It's flashing away to tell me that panel 2 is talking to me. I'll hit the key to talk back to panel 2. And it goes red to show me on the display that I am currently talking, and I'm also listening back the other way. And I can reject that call because panel 2's key does not have a force key. So I just show you how quickly and easy it is to do something like that. How very simple it is to set up a key to talk and listen. Just go through a few of these keys. Well, I use the manage key to open the web page of panel 1, and use the remote control. I could equally pick up belt pack 1, which I already had open. This is a remote control of the belt pack, which I think is pretty cool looking. I have control over volumes and stuff like that. There's nothing configured on the belt packs at the moment, so they won't be doing anything. Assign, this is where I would assign my devices to zones and scenes if I wanted to, if I had any. Add's really cool. This is where I can, well, Peter was asking me about offline. If I had a panel called Peter that I was going to be adding to the system there, and I knew this panel was going to be coming through the mail, and I wanted it to take on the role of panel 2, I can copy that and copy or replace it. I'm going to copy it, and my panel called Peter now has got some keys. Well, I might as well give it keys to talk to everybody else, and everybody else is going to want to talk to Peter when that panel turns up. So I can start programming it like that, where when that panel comes in the mail, I can plug it up to the system. It will appear as an icon with a red exclamation point, and I would drag this repeater image onto that panel, and it would automatically start working with the other panels, would become part of the system. Sort by name, well, just does what it says, changes the sort. Sort by IP address, well, you can't see the IP addresses on here.
Quick question. How fast does the dashboard respond to the plugging in of a panel? How, like that panel you just talked about coming up with a question mark, how long does it take to appear?
It doesn't cycle through all the time, so it can be between 30 seconds and a minute. If we had it cycling the whole time, it would be a problem with audio traffic. So it does take a little while to find it. It's not instantaneous. We are looking at that to see if we should speed it up and make it.
Maybe there's a manual way to do it.
Not really. I mean, what can happen is if you make a configuration change and somebody just at the time somebody's connected a new panel, it will then automatically have done a scan, so it will have found it. I've actually asked the dev guys to put a force button in, so I think we will add that so that you can.
That applies to belt packs and panels that are already programmed and already been on the system. How long they take the same up to a minute time to appear? Yeah,
and also to disappear as well. You know, if I unplug something, you won't see it. You won't see it disappear immediately.
Okay.
Yeah, we need to fine tune that a little bit. I mean, I recognize that as being a failing. I'd like to speed that up. It can't be too quick. You know, we can't have it scanning every half a second because there's audio traffic on there as well. We don't want to cause any issues like that. But
does everything run on DHCP?
Can do. So if I go on to
your preferred way?
Personally, no. I mean, actually, I don't have a DHCP server on this network, so I couldn't do it anyway.
Well, it could be default 169, you know.
Yeah, no, we've so you can set a panel up to DHCP mode. I run them manually, but just because, as I say, this network doesn't have a server on it. But what we've tended to find is that people in the broadcast community like fixed IPs. People in live sound or in mobile production prefer DHCP, and sometimes it's a mixture of the two, and they might reserve the channel numbers and work that way. So it's a real mix, and that's why we've done both.
Certainly, actually, as an item from a rental house, which you have to do in show prep, it would be a little awkward to have to set the IPs on the bell packs for every bell pack in your system.
Yeah, no, I agree with you. And they do default to DHCP. So when they're fresh out the box or after you've done a reboot, they'll go to DHCP. So
right. Okay, cool.
Yeah. Okay, so where were we? Sort by IP, sort by type, expansions. Now you can see the expansion panel is kind of shaded behind there, and if I had lots of expansion panels, there'd be a whole load of them shaded. But we can go onto the expansion panel and log into it just to look at its configuration, and not a lot you can do with an expansion panel, honestly, but that's the web page for the expansion panel should we need to get into it. Okay, so that's the
if people have a bunch of expansion panels, can you look at their main panel and their expansion panels all in one view? And drag and drop the keys to fill it?
You can certainly drag and drop the keys to fill it. I mean, if you had another expansion panel on top of here, that it would show on there, so you can configure it in one go. You can't open them together at the moment. You know, if I hit manage on here, it will only open panel 1. It's because, I guess, because there is the majority of the configuration for a panel is stuff like you know, changing the mic gain and things like that. But
the expansion would show on this screen right here.
Oh yeah,
with panel 1, so I could have 5 or 6 expansions and panel 1.
Yeah, it will. Yeah, I mean, once it's assigned to a panel I'll tell you what I'll do. I'll take it off of here, and you'll see. So if I take the expansion panel off of there, update the system,
Right.
it doesn't show on there. It shows in here. So we've hidden it so there's no confusion, because you can't configure it unless it's part of another panel. So I want it to go back to being part of panel 1. So I drag it as an available expansion panel, I attach it, and now it reattaches. And if I'd had any keys on it, it would have picked them up. What happens when you this is interesting actually. If how can I do? I'll just show you this quickly. If I put a couple of keys on an expansion panel like that, and for whatever reason the expansion panel gets detached, let's say somebody unplugs it, those keys get automatically put on the shift page. When I reattach the expansion panel, they go back to where they were.
What if
So-
there's keys already on the shift page? How many shift pages are there?
There are 3. If there are keys already on the shift page, it will ignore them, or it will put them further back.
Okay.
I've never tried that. That's a good question. I shall try that. We'll
Our
see what
job is
happens.
to break systems, so we're trying our best.
I totally get it. I totally get it.
Got it. Got it.
Let me just get rid of them. Okay, so where was I? I went through all of that lot. I mentioned about the search tool. This is quite useful. Let's say I just want to find. Let's imagine it was a bigger system and I just want to find Peter. There we go. If I start typing into there, it narrows down the view. That's particularly useful on this side because maybe I want to find the program feeds on my incoming streams. Just press program. Okay, and that leads me neatly over to this side. So inputs and outputs. We used to call these sources and destinations, but they became a bit confusing for people who weren't familiar with IP. These are 4 wires. So they have an icon like a little arrow to tell you that they're inputs, and conversely, these have a little indent to show that they're outputs. So they're coming into the system or going out of the system. There are a lot of them on here, which makes it seem like it's a very big system. The reality of it is that on here we have the hot mics from each of the panels. We have the auxiliary outputs as well. So panel 1, for example, has 3 streams associated with it as inputs, and I've got a bunch of panels and a bunch of belt packs. So there's quite a lot going on there. I also have the mixing console, which has 4 program outputs. They all appear on here. I have a mixed signal X node, which I'll get to in a little while, as long as I don't run out of time. And that has 8 4 wires associated with it. And on my laptop behind me, I also have an AES67 virtual card, which has got let's see, that many. How many that is? 18 4 wires on it. 18 streams. And I also have some link stuff programmed up on here somewhere. Yeah, link. So I've got a key for talking to Cleveland, talking to my colleague Arta in Poland, and some unused link codecs as well. So these are all 4 wires in and out. If I double click on program, for example, if I look over to my console, I can see that there is audio on there. If I double click on that, it will tell me the live wire channel number. 1691 is the channel number used on that console for its program out. That's a live wire channel number. So if you're familiar with live wire, you'll know what that is in multicast. But if you don't, then we have a handy little calculator. But it's the live wire channel numbers were invented when live wire first came out as a means to help engineers who didn't have any understanding of what IP was to use audio over IP. So it's actually a concatenated number. It's I won't attempt to do the maths on here, but I can help out with a better explanation. But it's a multicast address, or you can enter a multicast address equally. If I go into advanced options, this is where I get to the Vox signal detection. I know there's audio on there, so I'm going to turn Vox on. I'm going to pick a -32 as a threshold, 2 seconds, presence on, gating on, update. Now, if I pull program onto panel 1 and I go to remote, you'll see it's flashing away. This is because there's program on there coming off my console, and if I hit it, you'll hear the band Jellyfish in the background, which is being played off of my laptop right now into the console and onto that key. So that key currently is just flashing away to tell me that there's audio on there. I've just dragged it on as a listen, so you know that could be a pre-hear mic, could be anything, but it's very, very quick and simple to do that. If I then click on that key and I wanted to do something like force it to listen, as soon as I hit that, that key will be forced into listen mode while there's audio going on. If I then just go onto my laptop and I stop it, that key, hang on, it's got latching on it. That's why it did that. Bear with me. I force it into listen mode. So I turned it off and I forced it into listen mode. I stopped the audio and now it goes out of listen mode after 2 seconds. So by using the Vox detection, I can force that key to listen. But I don't want it to do that, so I'll turn it off because it'll just be irritating in the background. As good an album as it is. Right, let's, I'm very conscious of the time and there's still quite a lot to go through, but those are the inputs and outputs over there. Now manage will do what it does over on panels. If I pick something that has a web page to it and hit manage, it will open it. Now this is the X node. So this is the analog, but it's a mixed signal X node, so it has a bit of analog, a bit of AES, and a mic input on it. And this is how you configure it. It has sources and destinations that you can name. So 8 sources in, which is 8 streams in, 8 streams out. If I give them a name on here, those are the names that will appear in dashboard. So if I change this one that says Mike to say Kelly and update it, and then go into dashboard and look for Kelly, there it is. It's done it in real time. So that was my X node. These are the channel addresses that I've set up. And again, I've used live wire channel numbers, but those live wire channel numbers do equate to, I haven't got anything to open that with, but they do relate to multicast addresses. And the configuration tool for an X node looks like this. So I have my physical inputs down here. In this case, it's 3 stereo analog inputs, although I'm using them in mono, so I'm using like 4 wires. 1 AES3 input and a mic input. You literally just patch them as you need them to your outgoing streams, and you patch your incoming streams to your physical outputs. So as a throwdown box, this is super easy to configure. You can also do things like mix things, or you can mono stuff. You can slug the gain on it. Maybe I want 6 dBs extra on the left-hand side of that stream coming in, or maybe I don't.
Do they always have to be done in pairs in stereo, or can you do one at a time?
You can do them one at a time.
Or they have different, in other words, they look like they're always in pairs.
The streams are always in pairs because they're stereo streams, but you can just pick up one side of them. I mean,
So
if you
that first one that is camera 1, 2, 3, 4, is that basically channel 1, channel 2 on the camera, or is that a stereo feed to the program of the camera?
well, this is the incoming stream from Infinity,
Right.
and what I'm doing with that camera 1 is I'm patching the stream down a mono output. So line 3 left is my camera 1 feed. So my camera feed will be in line 3 left, and camera 2 will be in line 3 right. If that makes sense.
Okay, sure.
Yeah.
And where do you label all those inputs and outputs and define
they're-
whether or not they're left or right?
So they're labeled in here, but and you can see here camera 1 line 1 left, camera 2, these are the inputs, camera 2 line 1 right, camera 3 line 2 left, and that's just reflecting the patch that I've made. If I go to the destinations, you'll see that it doesn't actually tell me the camera patching down here.
So in that prior screen, where you're naming them,
Yeah,
you can define it as stereo or not stereo.
well,
System mode, stream mode.
the stream mode is going to be stereo. Okay. You can make it 5.1 plus 2 as well, but on an analog X node. But let's stick with stereo. The streams are stereo. Within Infinity, they are used as monos. They're automatically monoed inside Infinity. It doesn't really matter that they're stereo streams inside the X node, because what we're doing, because our 4 wires tend to be mono, is we're just using the mono side of the physical connection. So this line 1 left is a physical analog output on the back of the X node. So it's kind of irrelevant, you know. I can just do that,
Right.
and it won't make any difference.
Is the stereo a function of AES protocol, or is that what you're talking about, or?
Yeah, it's a function of AES67. So these
okay.
this is a stereo stream. It's kind of the lowest common.
Got it.
The lowest denominator of AES67. So the Infinity system is built around, as are actually all the Telos products are built around stereo streams. But within Infinity, we handle them as mono. So a product like the X node, which comes from the radio side of the business, it's expecting to see stereo, but it really doesn't make any difference. It's the only difference is I ticked one extra green box. That's the only difference it makes. So that was just showing if I click on something and open it, it will open the browse window of the device that I'm looking at. Now, assign is much like it was in panels. If I hit assign, I can assign a 4-wire to a scene or a zone if I had any active. Add, this is where you get into doing stuff like connections to a Dante system or a Ravenna system or something like that. So if I'm adding a new input and I give it a name, I call this one Mac, and if I gave it a channel number, which is a multicast address, I'm not going to do this, but if I gave it a multicast address, or if I had the STP information because it's coming from a third-party AES67 device, and I just drag and drop that SDP file into here, it would auto configure the channel, and when I hit create, that will appear in this IO list, and that will give me a connection to that incoming source. If I've got a Dante system I'm connected to, and I go to the SAP tab over here, this will automatically find any Dante system streams that are being advertised. It will only populate them if I go and find them. So if I'm looking for something like Yamaha program, and I hit Yamaha, it'll go and find the Yamaha program inputs, and it will give me the icons. I will click on it, create, and add it to the list. And those streams that I've picked up from the outside world will be, excuse me, added. Excuse me, will be added to the IO list. Conversely, if I'm doing outputs and I hit the add button, it's a little bit more simple. If I give a name and a channel number and hit create, that multicast channel will be spun up inside the Infinity system as an output. So any third-party device that wants to connect to it can take that information and can subscribe to it. If I want it to appear in the Dante controller or in Domain Manager, I hit enabled. It will start advertising its name with SAP advertisement, and you will be able to see it and connect to it. There are a couple of caveats there. It needs to be within the range of multicast addresses that the Dante system is programmed to receive, because it does have a limited range, and you can find that within Domain Manager or within the Dante controller. So that's how you connect to the outside world. Now, we don't automatically discover everything from outside, and we don't automatically create outputs. We let you do that manually, and part of the reason for that is because if this was on a large system, connected to a large system, let's say it had a big production console on there that had 256 Dante streams, you probably don't want them all to appear on this list when you only want 4 mix minuses or a couple of AUXes. So one of the reasons for adding them manually is to be respectful of the fact that you only want to build the system that you want to build. It would be, you know, it would be, you know, a little bit. It would make the system much more hard to handle than it needs to be, arguably. Okay, let's do something fun like build a party line. So down the bottom right corner, we've got IFBs, party lines, and groups. This is where we create them. We want to add a party line to this system. We hit the add button. We're going to create a party line called 1. It's going to appear that color on any key we put it on. And we've created a party line, and I need it quickly, so I'm just going to drag it onto that panel. I'm going to drag it onto that panel. I'm going to drag it onto that panel. And I'm going to drag it onto that one. And that one. I'm going to drag it onto the first belt pack. And then I'm going to copy that belt pack to every other belt pack. So I've just put, oh, I missed Peter off, but all right, there we go. I put that party line on every device on this system. They're all sat there with a key, and they're all able to talk to one another. Now, if I press that key, it's going to sound like Jimi Hendrix in here, because all the volumes are turned up, and none of my belt packs have got headsets plugged into them. So just to show you, oh, yeah, there we go, started to feedback. That's because I've got 4 belt packs sat on a flat surface with all their volumes turned up. And although this has fantastic echo cancelling built into the system, uses a Fraunhofer echo canceller, that's pushing it to do that. But that party line key is on there. I'll just mute the mic so it doesn't do it. What you'll see if I go on to another panel, let's pick 3. You'll see the party line key is flashing. It's telling me panel 1 is calling me. If I then go onto my belt pack, and I can't mute the mic, but I hit talk belt pack 1, and I go on to there. You see party 1 belt pack 1, party 1 belt pack 1. Go on to panel 3, it tells me who's calling me on the party line, which I think is a really cool feature. If I then drag my program in, my 4-wire, every device on the network is now playing that audio, and it's even telling you what the audio is because it's got Vox Detect on. So it's saying program 1, panel 1, belt pack 1 are all talking on the party line right now. Let me move that out. Not that. There we go. So that was just a quick look at. Let me stop these mics from being open. BP1. There we go. Okay. That was just a quick show how quick it is to set up a party line. Absolutely incredibly quick. IFBs aren't much different. I've got one here, but I'm going to create another one. Add an IFB. When I add an IFB, I can set up the dim level. They're preset with no dimming, 6, 9, 12, 18 dBs of attenuation, plus a complete cut. We used to have a little fader on here, but it was a bit difficult to use. So we put these graduations on here. Each one of those graduations represents a different priority level. So let's say, for example, panel 1 is assigned to level 1 and panel 2 to level 2. It means that panel 1 will take priority over somebody trying to talk to the IFB on panel 2. We'll call this one IFB 2, and wherever it appears on the system, it's going to be blue. Actually, purple. I haven't used that. So create IFB 2. I'm going to pull in program 2 because I know it's got some audio on it. I'm going to go to IFB 2, which is on the X node. And now, if we go over to our little X node now and look at its meters, we should see line 1 left and right. It's got my 2 IFBs on it. IFB 1 was already programmed. IFB 2 has just now appeared. They've both got the same program because that's what's coming off of my mixing console. Although one side is program 1 and one side is program 2. If I drag that IFB onto a panel, onto any panel, they'll automatically be assigned to level 1, and then I can move them around if panel 1 is my priority and panels 2 and 3 are lower. So if I hit the IFB, that will be talking, and that was IFB 2, which is on that channel. As you can see, it's ducked it by 12 dBs. If I clap my hands, this is a bit where I remember I muted the mic. I clap my hands now, you'll see that level shoot up because I'm talking over that IFB. Panel 3 has a lower priority, so panel 3 is currently not talking over that IFB. It's only the mic on 1. The only way I could really show you that is by turning around, but let's mute mic on 1 and go back to the belt pack, and you'll see that's not bumping up and down when I clap my hands. But if I then release that so that panel 3 is still talking over the IFB and clap my hands, you can see now panel 3's got priority. So that was how easy it is to build up an IFB. Reverse over there, that would be your hot mic. So that could easily be a hot mic from my system. More likely it'll be a mic from it'll be the talent mic, which I don't have one handy, but I do have some mics kicking about. So I'll pull on that mic, which is off panel 5's mic. And now those IFB keys now have become talk and listens, and I can listen to that hot mic. If I scratch it, you may have been able to hear that, but that's me listening to the hot mic of the associated IFB. So that's IFBs, really, really quick and easy to do. Groups. Difference between a group and a party line is that a group is sort of a target. You're talking to a bunch of things, and those things you're talking to don't talk to each other. A good example are cameras. So if I create a group called cameras, and I drag all my, to make it easy to find them, all my camera keys in to the system like that, all my camera channels, which are all on the X node, if you remember, and then go and get the outputs, and drag them all onto there. Now, I would normally have put these cameras on a virtual port, but I'll do that. I'll show you that in a sec. So I've got a camera key. I'll drag it onto panel 2 and panel 1. And there we go. And now go to panel 1 remote. It's got a camera key. It's listening to all those cameras. And now I'll just go onto the X node, onto the meters. The cameras are around, can't remember which channels they are. I think it's those. I go onto there and then back again, and it's not working. Damn. Best laid plans and all that. I'm not sure why that's not working. What have I done wrong? It's usually something. Usually the simple thing. I've muted the microphone. So there we go. There are my 4 cameras. I'm talking to them as a group. Okay, so that was as easy as it is to set up a group. I can't talk back the other way. I've got no way to do that. I don't have anything plugged into the X node that's going back the other way, but you'll have to take my word for it. So that's talk and listen to a group. Next thing, virtual ports. So we talked about virtual ports. I'm going to get rid of that group because I'm going to do this differently. A virtual port is a logical pairing, and I hit the add button, of 2 associated inputs and outputs. So if I create a virtual port called camera 1, it creates a little thing with an input and an output. Camera 1 is an input to the system. Camera 1 is also an output to this, is an input and an output pair. You see there, you can see why we've used these symbols. So that's camera 1. And I can have a key that talks and listens to camera 1. Simple. On panel 1. So if I go into my X node panel 1's going to be that one. I think it's line 3 left. And I hit the camera 1 key and talk away, and there we go. Audio on line 3 left. And if I had any audio going back the other way, you'd hear it. But as I said, I've got no way to replicate that easily within the system. Let's just turn that key off. And I'm just going to create another one. I'll create camera 2, and I'll stick camera 2's I/O in there as well, because what I want to show you is how these work in ISO mode. And then put camera 2 on there. Now, if I go back and create a group called cams again, and I do it differently this time, I drag the virtual port in there, and then I pull that camera key on there. So on my panel, I've got camera 1, camera 2, and all cams. So now I select all cams. I'm talking to those 2. Or if I talk to them individually, I can do that. All right. Now, if I put that group key onto another panel, like panel 2, and I'm on panel 1 and I want to have an ISO conversation with the cameras, meaning that I want to take a particular camera out of this group when I talk to them, the way I do it is this. I go to the key and I simply do that, ISO disable. sorry, ISO enable, and now how can I demo this? Let's say I'll talk to, I'll go to panel 2. I'll talk to the cameras on panel 2. So I'm doing that. I'm going to mute the mic on panel 2. So I'm still making the key, but I'm not talking to them because the mic's muted. But I go to panel 1 and I'll hit the ISO key for camera 1. And I'm talking to camera 1. I don't think I've got an easy way to prove that I've taken that out of the group. You just kind of have to believe me, I have. If I go back to panel 2, unmute the mic. Oh yeah, this will do it. I'll mute the mic for panel 1. I'll go back to there. Now, I'm only talking to camera 2, although I'm using a group key on this because I'm talking to the ISO camera on that one, but I got my mic muted so that you can see that there's a difference. I hope you followed that. It did my brain in setting it up, but it worked. So that's just showing how ISOs work on the Infinity system as well. Okay. I'm really, I've only got a few minutes left.
We've got a few questions if you got a moment.
And take your time. We don't have a hard out, Martin,
Yeah,
but
we don't.
I obviously want to be respectful of your time.
All right. Usually these webinars go till 9 or 10 p.m. So we got plenty of time.
I know you've got another one following me. That's the thing.
No problem. We know those guys too.
I know it's
Exactly.
only Gary Rosen, and he's been sending me abusive messages all afternoon. So it's what I'll do while we're in here. So that was ISO, and I don't want to miss anything, but shift pages, device management, web pages. I've got a crib sheet here, just so I don't miss anything. Snapshots. Okay, so this is a cool configuration. I like this configuration. It's the one I'm going to use on my show tonight. So I'm going to take a snapshot. I hit the snapshot button up there. I'm going to call it Tonight Show. Thanks, Gary. Yeah. Yeah, Gary just messaged me. It came up on my watch. Tonight Show. So I created a snapshot called Tonight Show. Okay, what it's done, as soon as I created it, it's taken me offline. Live isn't lit up anymore. So I now have a snapshot called Tonight Show. I go and drop down menu, and there's my snapshot. I can do several things. I can clone it, and then I can edit it. So that might be Tonight Show midweek. I might want to clone it and create Tonight Show weekend, you know, and make some changes to it. Equally, just to show you how this works, if I go back to here, and I've gone back live on panel 1. You see panel 1 looks like that. Looks exactly the same as the live configuration. I'll take those keys off because I don't need them on this particular show. And that's my live state. But I'll go back to the Tonight Show and push that to the live system. So I hit set. This will overwrite the live system. Do you want to continue? It's always good to have these things. Yes, I do. And it's put those keys back, the keys that I removed. So that's put the live system back. So snapshots are kind of easy as that, really. You're just saving as many different configs as you like. You can create a default config and you can build from that, or you can or you can edit the ones that you've got. You can do offline editing. So if I go to Tonight Show now and I've missed something off of here, I haven't got IFB1, I've got to have that on there. That's in real time, that's updated Tonight Show. It's put IFB1 on there. So Tonight Show now has IFB1 on there. That isn't on the live panel, but it's on Tonight Show. So if I push it and go to the live system, well, there you go. That IFB is now on there. So I've put it on that panel and it's there. So you've got lots and lots of flexibility here. You can make lots of changes and do stuff like that. we talked about zones before, and we don't have any zones at the moment, and I normally do zones first before doing snapshots because they sort of work inside and outside of one another. But if I go to zones and add a zone called Studio 1 and create that, now I have a zone with nothing in it, and I want to put some things in it, so I'm going to put those panels, those belt packs, and I'm going to add those to, not add, assign them to Studio 1, and I'm going to pick those and add them to, did it again, see that? Can't even program my own system. And we'll pick some of these and assign those to Studio 1 as well. So I've got a little system called Studio 1. I'll also pick these two IFBs as well, and I'll stick them in there too. So this is my whole system, but I'm an engineer who's working on zone 1. So let me go and grab, sorry, on Studio 1. Let me go and grab that and hit the filter. And now my entire viewport of the system is just those things that I want to work on. I can go into administrator, and I can look at the permissions for my user, and I can say my user's actually only got permission for that. Let's assign them. So I can go into scenes and say, well, he's working on the Tonight Show, assign. He's working on Studio 1, assign. And that's how you give different users different access to different parts of the system. And I can clone that Studio 1 zone. I can create another one. Let's do that quickly. Add a Studio 2. And in Studio 2, well, I can't really remember what so go back to the complete view. I can't remember what was in Studio in Studio 1 now, but I'm pretty sure it wasn't these things. So let me go and stick a few things in Studio 2 just for illustration's sake. So now I've got a Studio 2 set up and a Studio 1 set up. And there we go. There's that other studio that I created. I didn't pick any outputs, and I didn't pick anything down here, so you won't see them. But yeah, I might be a user who's only allowed to see that, or I might be a super user who can see both studios, or equally, I might be the administrator who can see absolutely everything. Now, I talked about being able to target firmware updates to different studios, and just to show you how that works, I don't have any firmware loaded in the system right now, but if I upload some firmware, I've got to go and choose a file. This won't know where to look because I rebuilt my PC earlier, but I might be able to do this quickly, or I might not, I'm not sure. Software panel, there you go. I'll pick some panel software. I'm definitely not going to throw this at the system because this is really old, but if I upload that file into the dashboard system, I have some firmware here for panels. And I go into zones, and Studio 2, it tells me I've got firmware here. If I click on that, apply, I'm not going to do it, that will send that panel firmware to all the panels that are in Studio 2. Okay, so that's how that firmware updates and how you can target it at different areas. So yeah, that's
now I assume it interrupts the operation of those panels when you're doing a firmware update.
It does very briefly. It knocks them out for about I think it's about 5 seconds when they go into, because they automatically loads it into the software bank, and then and then makes it the active version. If
So
you
that's how long the entire firmware update takes, is about 5 seconds?
The software update takes slightly longer than that, but the changeover is a few seconds. What you can do, if you wanted to do it individually, you go into the maintenance page on the panels, and you could upload new firmware into the secondary bank. There's always a second bank. So currently we're running 1.626 firmware on bank 1 of this panel, well, every panel for that matter. If I had new firmware to add, I could upload it into bank 2 on a panel by panel basis and then switch them over. So I was just
how long is that panel offline? How long does the user not have use of the panel?
It is a few seconds. It's about 5 seconds.
Okay, so the whole firmware process only interrupts about 5 seconds. So it's not not a thing where you have to wait for the end of the show.
No, well, yeah, no, it's up to you. I mean, you can send it to the system. If you do it via the dashboard loader, it will automatically assume that you want to start using that firmware, and
right.
it will flip the panel over. If you do it device by device, it's up to you, and you can choose when you flip it over. So
did that save you any time when you flip between 2 different firmware versions? Is that more instantaneous?
No, the time's exactly the same.
Okay.
The difference is the methodology. It's whether or not you can do it confidently when
right.
When the system's not, that part of the system isn't live. So it helps to be able to do a bulk update, but equally you've got to know that your system's not going to. I'll give you an anecdote. I installed a Trilogy system down in New Zealand back in 2000 and something, the early 2000s. We worked for 3 weeks installing the system. We got asked to do a system configuration change in the middle of the very first show on a Monday morning, which is the news show that goes live to New Zealand. We were sat in master control. We'd worked a 48-hour shift, and we'd only got a couple of hours sleep, dog tired, and during the ad break, somebody came in and said, you need to go in and change the labels on some keys. The Trilogy system at the time couldn't do a live update. You had to do it offline and push it. And I said to the master control guys, are we off? Can I do this? Because it's going to take it down for about 10 seconds. And he said, yeah, you can do it. No, we're off. You've got plenty of time. We're in the ad break. He was looking at the wrong channel. We weren't in the ad break. I pushed it live to the system. And then I looked at the screen and I watched in horror as the presenter, the news talent, was interviewing a politician from Auckland down the line to Wellington. And the beauty of it was that you could see the politician doing this, on their earpiece. They couldn't, not being able to hear. And the question was, what do you think about the farming subsidy, or some political stuff? And the politician went, I think what you're trying to ask me is this. And then they talked about whatever the hell they wanted. So I've seen firsthand the damage that can be done of doing an update in a live scenario when you shouldn't do it. So we do have that safeguard in there. However, if you're interviewing a politician, it doesn't matter, because they'll ignore the question anyway, and they'll say whatever the hell they like.
You want to take a couple of these questions now?
Yeah, go for it. Let's do that.
John Christie asked, does it use OCA AES 70 for those GPIO ports?
Not currently, no. We're talking about that. We are part of the OCA. I know that inside the company there's a lot of interest in doing that, and I suspect it's something that will come out in time.
Is there a global color palette you can do to change all your colors, or is that set on an individual basis, like all party lines are red and all IFB keys are blue?
Yeah, so you can, like party line 1 is whatever color that is.
Right.
I can change the color of party line 1 on that key. I can make it blue, but party line 1 is still that color. So it's global if you do it when you create the party line, the IFB or the group, and it will also ripple through if you change the color.
But if you want to make all party lines the same color,
No, you can. No, you can't. You'd have to do them one at a time. We always had this
Okay.
sort of idea that people would want to, separate things up. But I can understand you might want all your party lines blue and all your IFBs orange or something. So yeah,
Right,
I get it totally. But no, you
John
can't do them.
Christie also asked, same question, he noticed that the DIM priority only seemed to have 3 sockets on DIM 2. Does that mean only 3 panels can operate in DIM level 2? Or did
No.
it just add one more blank slot after the list?
Yeah, exactly that. That was in this one, wasn't it? No, it would add it'll add another slot. So if I put 5 there and then put 2's already in there, put 4 there, it'll just keep adding them, and you can just keep going.
Okay.
Yeah.
When you respond to a group call, if you hear a group call and respond to it, does the responder create a point-to-point with the caller that the other people don't hear?
Only when it's in ISO. Only when it's an ISO conversation.
So a responder to a group call is heard by the whole group?
Yes. Yeah, or everybody with the listen key for the group. So a responder won't talk to the other members of the group. That would be like a party line. If the cameras talk to a caller to the group, they will talk to the other callers of the group, but won't talk to the other cameras. But it's not like no, I think one of the other brands has got a private response mode to groups. It doesn't work like that. No, it's global.
Well, so if you have one person talk on a group and a lot of people are listening, don't have listen capability, but they're talking to the group.
Yeah.
They can only talk back to the caller.
Yeah, I mean, if other people who can talk to the group don't have listen capability, they won't be able to hear it. You can choose the key. You can choose the key mode for that. Yeah.
Howie Feld wants to know: is there a 2-wire interface to third-party equipment, like if you wanted to plug into a old-style 2-wire system?
We've always pointed people towards the studio tech. We don't have a 2-wire ourselves, so I've always said if you want a 2-wire interface, and Clearcom have got one as well, go 2-wire to 4-wire, or 2-wire to Dante.
Got it.
And we've always just said, look at the studio tech box and use that. And we've had a couple of people who've used them, and they've been absolutely fine.
Can you make program listen not blink?
Oh yeah. If I turn off if I just turn off the box on there, it won't blink. But it is global.
Okay.
Having said that, it's global because it's assigned to the source.
So when you turn that off, it won't blink anywhere.
Yeah.
Can you individually make a key blink when audio's on it? On a per panel basis?
No, not if you turn Vox Detect on. No, you can't. At least I don't think you can. I'm pretty sure you can't. Let's have a look.
Okay.
No, it will flash. Yeah.
Okay. Does the snapshot apply only to the selected panel or for the whole system?
Snapshot applies to everything that's in the view that you're looking at. On
all 4 sections in there, right? This screen right here. Okay.
Yeah, exactly. I mean, you can add things to, so if I took a snapshot in that screen that's up there now, it will snapshot everything that's in there. If I was in a zone view and I took a snapshot, it will snapshot everything that's in the zone. If I then decide that I need something in that snapshot that wasn't there when I created it, I can manually add it. So I could add this IFB to well, it's zones, but no, I would had to have snapshotted that when I'm not in scenes at the moment.
Right.
I can add things into scenes that weren't there.
Now, when you switch to a panel and remote control the panel, is that functionality always on, or is it something you toggle on and off? What if you didn't want to accidentally remote control a panel?
Well, so a panel. Well, what I'm doing there is I'm remoting into that panel. So I'm browsing to it, and I'm using the manage key to get into it. Now, what you can do is password protect the panels, so that if somebody's using dashboard and they hit manage and they don't have the password, they won't get into it.
So basically, anytime you click on a panel there, you're remoting into the panel. And as a dashboard user, you have always remote control. So you just have to be careful.
Yeah, I mean, we're just about to add it actually into the next release of dashboard, that there's a remote control key down here.
Got it.
And when you hit that, it will pop up a docked view of that screen.
Okay.
So that you can have now I think we probably want to be able to turn that off.
Yeah,
because
exactly.
some people will believe that that's is a dangerous thing to have, and I tend to agree with them. So
Sure.
first thing is get it there.
Exactly. Can panels or belt packs have 2 ear headsets which are stereo or hear different channels of program?
No.
Like with 5-pin connectors?
If we okay, so the short answer is no. There's a longer answer. The way that the plastics are made on the belt pack, on the bottom of the belt pack, and it's the same with the panel, it's a fixed mold and it needs a male connector. Okay, you can't put a female in, because it's the mold's just not big enough to take it. If somebody wanted
Technologies has a fix for that.
They do. If we put a 5-pin male in, as a special order, and
Right.
and I have to say the hardware, the panel hardware, is capable of doing that, because we have a stereo headphone driver built onto the CPU board. If we put a male 5-pin in, you could put an inline gender bender, and use a standard 5-pin headset.
So in the dashboard, there's programmability for different channels to the headset?
In the belt pack there is, yeah. I don't think it's in the, so there's a mode there. There's a mode switch. So stereo mode will do a split.
Right.
But it would only do it if you had a specially ordered belt pack. And currently we don't offer it. What I would suggest anybody who needed that, talk to your salesperson or email me.
2 questions left. Peter Mason wanted, so I probably missed it, but how does the Firmware camera intercom interface? What hardware do you use? You
would use an X node. So an X node is an analog to IP converter. I've only got the picture of the browse window on here, but the information is online. So an X node has a row of analog connectors on the back. So it's one X node could do 8 camera channels.
Right.
It has D subs on there, which I believe are pinned the same as Tascam.
Got it.
And it also has RJ45s, and you can use the Studio Hub breakouts.
Okay. On a power cycle, intended or otherwise, will the new firmware load? Or is that only a manual push?
It's a manual push. It won't automatically. It'll come up in whichever RAM location you put it in. So
okay.
If I power cycle this panel right now, it will come up in firmware bank 1, unless firmware bank 2 had been the active
right
bank.
Where it was left, it will come up. Okay, that's obvious.
Yeah, exactly.
Where does the dashboard web server reside? In every piece of equipment?
There is a web server in every piece of equipment, otherwise we couldn't do this remote. And so you don't have to
in this dashboard, when we initially log on to the system, we pick whatever device we wish to. like a permanent panel, and make that our main connection, correct?
No, there is no main panel. So there is a
I
web
mean,
server.
whatever panel we wish to make are in our mind our main panel.
No. So no, I think I've confused you. Dashboard is running on, in this case, dashboard is running on my laptop behind me. So if
Okay,
if I just use Google Share to my laptop, get rid of that. This is local services on my laptop.
Got it.
And down
Okay.
here, God, there's a lot of junk running on here. Down here is Infinity Agent and Host. And Agent has set up a database on my laptop, and that database is discovering the system, and the host is giving me is giving me the WebSocket. If I go to these folders here, program data Telos Infinity, that is the current database. As you can see, well, it's 10 past 8 in the evening for me in the UK. That's the database currently of the system. I haven't made a change to the system for 10 minutes, and that otherwise that would have updated. Yeah.
Well, that's the end of our questions. It's been a terrific show, and I know that there's a lot of people who want to see this, and we'll definitely do this show again. I was really impressed.
Yeah, and I must say, seeing the X-Node interface was very nostalgic, because it looks exactly like the old XE interfaces I used. Only with higher quality graphics, but other than that, it was pretty much the same.
Wasn't that Peter that had those systems?
Yes. Yeah.
And he still does, probably.
The one thing
I still has them, but unfortunately they were destroyed in the flood.
The one thing I missed is Link, which if I don't just touch on it very quickly, I'd be in trouble. So Link runs on can run on panels. This is the OPUS codec that allows you to connect remotely. Link is a code there, so there's the code which anybody viewing this video will anyway be able to read that code. If I go into Link on an activated panel, as I have here, these are the Link codecs. These allow me to create a peer-to-peer connection over WAN. Okay, so there are 8 codecs running on this particular device. I've got a couple set up, one to Cleveland and one to my colleague Arta. There's nothing on either of them, unfortunately, but these are IP connections. These connections then appear in the IO list. So if I look for Cleveland, there's the incoming signal from Cleveland, which is coming in through panel 2, but is available for the rest of the system. So if I want that audio from Cleveland, if there was anything on it, to go into party line 1, I just drag it there, and Cleveland would now be part of that party line.
Yeah, see, now we will have to do another one, because you just gave me like 6 different questions in my mind. So we're gonna do this one, and we'll jump into it in even more detail.
Yeah, it's almost criminal that today is the day GoToWebinar decided their servers were gonna be overloaded.
Yeah, but the good news is the recording has been recording. The show went on. Martin, that was awesome. I mean, man, this is like drinking from a fire hose, but you're like hooked up to 3 hydrants. So we're kind of doing a deep fast dive, and you hit all the spots. And like we said, there's plenty of other questions. Folks, reach out to them. And Pete, do you want to pull up the contacts one more time?
Sure.
Because I think that's something that is going to be important to folks watching, and being able to reach out to Martin and get these, because I was getting texts offline from, again, a lot of different people from different market segments than what we normally thought about. And of course, Pete is excellent at breaking systems, and great questions, Pete. And but more importantly, I think you strike us as the kind of company that wants to listen to the marketplace.
Oh yeah.
Make those changes where you can. Already you've been responsive with just the remote control feature there, right? So anyhow, we're gonna we're going to call it a day. We will be reaching out to you, Martin, to figure out, you know, how to cover the 6 questions I got banging around in this melon of mine, as well as touching on, you know, some of the key areas. And everybody, pass the word around. This is available. The rental cost is 0 for the video. You can rent this video as many times as you want, and you don't have to rewind it when you're done watching it. I just want you to know that. Shout out to Blockbuster. So if you don't have anything going on immediately, which no one should, join us for the CrewCom discussion that's going to start up at 4 o'clock Eastern. Not only will they talk about, you know, the interconnectivity, but I'm going to shut up so we can start that. But please join us. Plenty of room. I booked a big room, you know. Food's on you guys, though. Drinks and food. Bring it in. We don't have an issue. If you spill, it's no problem. The place we're renting the place from is all good with that.
Don't spill it on your computer, because then you'll miss the show.
Well, yeah, well, you know what? We can't help that.
Exactly.
Martin, thank you, buddy. I know it's late over there. I appreciate your time. You did good. Now go rest those pipes, and we'll get ready for the next conversation.
Thank you so much for the opportunity. I really appreciate it. It's been brilliant. And everybody stay safe and well.
Thank you.
You too, man.
It was a great presentation.
Cheers.
All right.
Goodbye.
Bye.